Hello everyone and welcome to my completion of task 2 of the data analyst intern in the Sparks Foundation. Here we're going to predict the optimum number of clusters and represent it visually from the given iris dataset. In this, I'm using k-means clustering, which is an unsupervised machine learning algorithm that classifies data without having been trained with labeled data. This makes any new data to be easily assigned to the most relevant group. For that, we import all the necessary libraries and we import the CSV file and we read it using the pandas library. And we are printing the last 5 rows of the data set. But as you can see, the ID number has been printed here, which is not necessary for us. It will cause further problems. I'll show you later. So therefore we remove it and print it again, and as you can see, the iris dataset doesn't have the ID number here. And now we are finding the unique values of all these species, and as you can see, they have quite a lot of them. And before we work on the data set, we're trying to find if there's any null values available in any of them, which might pose problems for us later on. So as you can see, we can describe the data set with the describe function, which gives us the number of observations, the mean, the standard deviation, and all. So to find the exact number of clusters that we need for the k-means clustering, we use the within cluster sum of squares, and then we select the number of clusters where the change in the WCSS begins to level off. As you can see, there's not much of a big change and after like the number 3. So now because of that, we choose the number of clusters for our k-means clustering to be as 3, and we create a cluster based on the classes 0, 1 and 2 and give them accordingly. So now let us move on to the properties I forgot. Before that, I'll show you again. As you can see, if I don't erase the ID number here, and we see and we print the elbow graph, we can see that the numbers are very different. That's because it includes the ID number also, and it predicts based on that. So now but if you import it from the sklearn data set directly, you can see that there's not an ID number given here by default. So now because of that, if I print it and see, there's not much of an error. So if you're like importing it via read CSV file, it's necessary for you guys to drop the ID column. Now moving on, as you can see, like it did give the power plot gives us a detailed representation of numerous features, and as you can see, Iris setosa seems to be the most distinct out of all of them, whereas the versicolor and virginica species seem to be most similar to the other from this power plot, as you can see. And now we can see the correlation between different variations and parameters. We're using this heat map, and as you can see, the petal length and petal width seem to be really similar. And now we can find the probability density of the species for given for given thing. And as you can see, first petal with centimeter, Iris setosa seems to be the highest. And now we use violin plots in order to get the median, interquartile range and the percentile. The yellow dot in the middle, as you can see, depicts the median. The more thicker line in the middle depicts the interquartile, and the more thinner line is 1.5 times the interquartile range. That's how detailed the violin plot is. The box plot is also similar to the violin plot, but it has a lot less features, as you can assume. And it's also based on the concept of median, percentile and quantile ranges. And as you can see, the bar plot shows a more colorful and aesthetically pleasing look at the supple width. And with the cluster map, we can see how many datas are truly there in this data set. It's quite a lot, as you can see. And now we plot the k-means cluster of the given data set, and we plot them using the scatter plot, and we mark the centroids in the middle. As you can see, Iris virginica seems to be the most distinct out of Iris setosa and Iris versicolor, unlike the ones in SNS par plot. That concludes my task in the Sparks Foundation. Thank you all for listening, and sorry if I've done any mistakes. This is my first time. Thank you.